In physics, we observe the motion of objects and use reasonable data to understand how different variables interact. We'll begin each unit with a lab during which we'll collect data to examine relationships between variables such as position, time, and velocity. Understanding the units of these variables helps us to derive equations so we can understand and predict the motion of the world around us. To begin, let's discuss variables. Variables are any factors, characteristics, or conditions that can be measured or counted. Some examples might be position or distance, speed or velocity, or time. When we conduct a lab, we're experimenting, observing, and collecting data on how two variables interact. Those two variables have very specific names. The first being the independent variable. This is the variable that you will be manipulating, you'll be controlling. You will decide how far, you will decide how long. This is also the data that's plotted generally on the x-axis of our graphs. We change the independent variable, hoping that we can see or record a change in the dependent variable. This is the variable that responds to the independent variable being manipulated. It's the data that's plotted on the y-axis. For every x, we hope that y happens. This is the data you measure. Let's look at a couple examples. You let a toy car drive a distance of 1.5 meters and measure the time it travels. What is the independent variable? What's the dependent variable? Well, we decided to change the distance. We said we're going to have the car drive 1.5 meters. We manipulated that number. We didn't record it. We decided we would use 1.5 meters. That's going to be our independent variable. Distance is going to be graphed on the x-axis. When we record the time or measure the time it takes, that's our dependent variable. On your own, see if you can answer what are the independent and dependent variables for these two experiments. One describes the interaction between temperature and yeast, and one is examining position versus time on a graph. In a lab setting, we'll mainly be looking at manipulating one variable and observing the other so that we can find a relationship between the two. But in order to find that relationship, we need to make sure that no other variables are causing the relationship. Things like temperature, friction, etc. Anything else that can be measured needs to be a control variable. It needs to be a set of variables that are never manipulated or changed. The only thing that should be manipulated, and the only things that should be observed are the two variables that you're finding a relationship between. They must remain constant in all experimental trials so the effects of the independent variable can be determined. If we're looking at time related to distance, but we end up changing a couple of things. One trial is on bumpy terrain. One trial is on really smooth terrain. That variable could overall change our data. A couple of areas that have great examples for control variables would be looking at the same number of trials. If you're changing the number of trials between setups, you may not be fully observing one set of data versus another. Looking at your setup, does everyone have the same job? Are you using the same measuring device? Are you on the same materials? Everything that's part of your setup and your process for running the lab needs to be held constant except for the two variables, the independent and dependent. Variables are measurable factors and characteristics. Whenever we talk about measuring something, we need to look at units and magnitude. Every value or set of values has a magnitude and a unit. The magnitude is the numeric part of that value. It's the size or extent of the value. The unit is what we're measuring. So our unit is any standard used for comparing measurements. You've grown up with units your whole life. Cups, teaspoons, tablespoons, gallons of gasoline. We're just going to expand that vocabulary to look at things and how objects move through our universe. This is what the magnitude of a value represents. When I say I have 3 cups of sugar, I have a concept of what 3 of those cups are. If I just said I have 3, I don't know what I have 3 of. Some common examples of metric units that we'll be using in physics include distance, which we measured in meters, not the empirical feet. Time, we'll be looking at seconds because we'll be looking at a smaller scale. All of our equations and constants will be based on seconds. So keep that in mind when you're looking at given values. And then velocity, instead of miles per hour, we'll be looking at meters per second because we're dealing with, again, meters in distance and time in seconds. The unit is what we're representing with our variable. The magnitude is how much we're representing. It's the size or extent of a measurement, the amount of each unit that is being represented. So again, go back to 3 cups of sugar. Cups of sugar is our unit. How many? 3. That's our magnitude. Negatives that can be attached to our magnitude. In math class, negative values mean a very specific place on a number line. In physics, negatives have special meaning, such as direction or a change in velocity. Let's apply these concepts to a real-world example and try to understand the 3 ideas. A car is driving at a velocity of 23 meters per second. Well, what are we measuring? What are we looking at? The car's driving, we're looking at its velocity. That's the measurable factor here. That's our variable. More specifically, we know that velocity is measured in meters per second. Again, a unit is how we measure something. And the size or the extent of how much velocity we have, in this case, how fast the car is going, is 23. So the velocity is our variable. It's what we're measuring. The unit is how we're measuring it, or how many individual units we're looking at. And then the magnitude is the numeric aspect of that, or it's the size, the extent, or how much of our unit we're looking at. On your own, examine these 2 examples to see if you can find the variable, the unit, and the magnitude. Or clarify which is the independent versus the dependent variable. When we collect data, we need to follow a set of very specific guiding tips. When we are in a lab situation, it's required that we change the independent variable a minimum of 5 times. That's going to give us 5 data points. 5 manipulations of the independent variable gives us 5 chances to observe and record a change in the dependent variable. The more data we have, the more accurate our graph becomes. For each time that you change or manipulate the independent variable, you need to run 3 consistent trials and take the average of whatever dependent variable you are recording. If I was measuring 5 different distances and then recording the time that it took a toy car to drive those distances, I would run the first distance 3 times, record the time each trial, and take an average. That'll give you a total of 15 pieces of data. But when you take the average at each change, you're going to end up with 5 dependent points. In order to help manage control variables, it's important that you make sure the same person does the same job for each trial and each situation. The same person who's measuring the distances needs to measure it every single time. The person who's running the stopwatch needs to run it every single time. Make sure that your data is reasonable. If on your first 2 trials you get 5 meters and on your third you suddenly get 9 meters, that last piece of data may have had errors. If the data seems off, just redo the trial. Don't predetermine your results. Just because you may have learned about some of these concepts before, don't assume that you know the outcome. The results might not come out the way you expected. You may go in expecting one thing and observing and recording something completely different. Be open to those results. We're scientists. This is all part of the scientific method. We're exploring relationships that have been observed and recorded in lab experiments like this time and time again. Make sure that your data covers a wide range. This is all part of deciding which independent variables or which values within your independent variable you choose. If you use 1 meter, 1.5 meter, and 2 meters, that's not as wide of a range as 1 meter, 5 meters, and 10 meters. So really you just need to choose a wide range of independent data. Always use the metric system. Remember, our variable is distance, our unit is meters, not feet. All of our equations that we'll be deriving and using in physics work only with the metric system. If you use imperial, so things like feet, inches, your answers will come out incorrect and inaccurate. If you make your observations and record your dependent variable in inches and your neighbor has it in meters, then you're going to have data that cannot be compared or understood.